All right, we're going to talk cardiac cycle and EKGs. Ready? Okay, so what actually is the cardiac cycle? Well, it is all of the events that occur in one singular heartbeat. One cardiac cycle lasts about 8 seconds. The cardiac cycle requires rhythm and speed control to be efficient. So our heart's not going to be that efficient if the cardiac cycle is all out of whack. So can't have it too fast, can't have it too slow. It's got to have controlled speed, but also rhythm. So we can't have like the parts not working together right. The cardiac cycle is separated into 2 parts. We have the electrical event that happens first, it's the signal, and then the muscular event, the contraction. So the electrical event, it occurs first and it causes the contraction. It's the stimulus, the signal. The muscular event occurs in the cardiac cycle. We're referencing the ventricles. So systole is contraction, diastole, relaxation. Just like remember with blood pressure, systolic and diastolic. So let's look at the events in detail. Okay, so we have the SA node, the sinoatrial node. It is the pacemaker of the heart, and it begins the cardiac cycle. Now, if something is wrong with your SA node, if your heart is not firing correctly, the pace is not correct. This GIF right here is just showing what happens with a pacemaker. We're actually forcing that SA node to signal correctly, okay? And then we have the AV node. That is the atrioventricular node. And it's important because it delays the signal. So the SA node up there in the right atrium is like, bam, contraction start. And then the signal goes to the AV node, and the AV node goes, hold up, let's let the atria contract. Okay, so that delay allows the atria to fully contract. So then the AV node sends the signal to the ventricles. Okay, so SA node, pacemaker, bam, start the contraction, goes to the AV node. The AV node goes, hold up, okay, and sends the signal to the ventricles. Okay, why does it delay? It needs to allow the atria time to contract to send the blood into the ventricles. Then we go to the AV bundle or bundle of His. And that brings the signal down the septum. So remember, SA node, pacemaker, start the signal, send it, AV node goes, hold up, okay, and then sends the signal down the AV bundle or bundle of His, which has a left branch and a right branch. The left branch going to the left ventricle, the right branch going to the right ventricle. Then we have Purkinje fibers. I love these. They literally bring the signal to all the cardiac muscle cells in both ventricles. So I need those ventricles to contract rhythmically, completely, and all together, not like this, one big squeeze. So the Purkinje fibers allow that to happen. So SA node, pacemaker, let's go. AV node, hold up. Okay, AV bundle, bundle of His, left and right branches, Purkinje fibers. So here we go. SA node, pacemaker. AV node, hold up. Okay. AV bundle or bundle of His, and then Purkinje fibers. And that's the electrical event that occurs in the cardiac cycle. So what are the 2 main parts of the cardiac cycle? We have the electrical event and the muscular event. So number 1, what's that? The SA node, the sinoatrial node in the right atrium. What's number 2? AV node, hold up. Okay, number 3, what's that? The AV bundle or bundle of His with the left and right branches. Number 4, what's this? Purkinje fibers, bring it to every single little cardiac muscle cell. What is the pacemaker of the heart? The SA node, the sinoatrial node. What delays the signal so the atria will fully contract? The AV node, right? Hold up. What brings the signal down the septum? The bundle of His, or the AV bundle. What brings the signal to all the muscle cells in the ventricles? Fibers. There are a few ways that we can monitor the heart. One way is with an echocardiogram or sonogram or ultrasound. So what can we monitor? Well, we can monitor the muscular events. We can watch the muscles moving, contracting, but we can also see the opening and closing of the valves. Like literally look, see those valves opening and closing? What a great way to monitor that. So why do we use an echocardiogram? To assess kind of the overall function of your heart. Make sure your valves are opening and closing, make sure it's contracting, make sure the blood is flowing correctly. Do you know anything about EKGs? Like, have you heard of that? Sometimes it's called ECGs, literally means the same thing. Okay, well, an electrocardiogram, also called an ECG or EKG. I'm confusing a whole bunch of things, just like echocardiogram. Anyway, it can monitor the electrical events in a contraction. So is the pace off? What about your heart rate? It records 3 waves. The P wave, that's when the atria contract and the ventricles are relaxed at this time. All right, then we have the QRS wave, okay? That's when the ventricles contract. So that's why it's bigger, right? The contraction is stronger in the ventricles. The atria also relax and prepare to contract again, but it's hidden because the ventricles contraction is so powerful. So you can see that the QRS wave is actually the ventricles contracting, and it hides the relaxation of the atria, okay? And then we have the T wave. And the T wave is the ventricles relaxing and preparing to contract again. So what does an EKG look like? Well, we kind of saw one single one, but it's going to print out and you're going to have a long strip of paper. It can also be recorded digitally. So this is how an EKG is performed. You have a bunch of leads attached around the heart, but also some on your legs because we're checking the electrical conductivity. And you will see atria contracting, ventricles contracting, ventricles relaxing. Why do we use it? Well, it provides information about heart rate, about rhythm. Are there defects in the electrical conductivity of the heart? Sometimes you might have a stress test done, and it helps doctors determine how your heart will handle an increased workload during exercise. So why would they want to do this? Well, to see if maybe you have some heart functionality problems, but also if you're at higher risk for surgery, they might want to do a stress test because surgery is stressful. So if your heart doesn't handle a stress test well, maybe surgery is not a good idea. So let's look at some actual EKGs or ECGs or electrocardiograms. So here's a normal EKG. Okay, so we have a P wave, a QRS wave, and a T wave. It shows a heart rate of about 60 to 100 beats per minute. Don't worry, you don't have to remember how to count them. Looks like this. Okay, a normal EKG. A normal EKG. There are a lot of abnormal ECGs or EKGs, but we're going to only focus on a few. So first, just arrhythmia. And you won't be tested on this in terms of recognizing it, but what arrhythmia means is irregular heart rate. So it could be a whole lot of things. So the spacing of waves might be irregular, but an arrhythmia is basically anything that's not normal. So you're not going to have to identify an arrhythmia, but to know that word, arrhythmia, is important. It means it's not rhythmic, so it's irregular. Okay, so the heart's not beating rhythmically. Something is off. All right, tachycardia. Tachycardia is an elevated heart rate. Your heart rate is above 100 beats per minute. So you see those, the P, the QRS, and the T waves, they're like smushed together. So tachycardia is an increased heart rate, and in an EKG you can see because the P, QRS, and T waves are smushed closer together. Bradycardia, on the other hand, is the opposite. Your heart rate is under 60 beats a minute. The waves are far apart. Okay, so bradycardia is slowed down heart rate. Okay, so under 60 beats a minute, your heart rate has slowed down. Okay. And then we have Afib, atrial fibrillation. And it's an irregular rapid heart rate, but the atria are like all over the place. The atria are beating completely out of rhythm. So normal is SA node, AV node, hold up, bundle of His, right? Purkinje fibers. But in Afib, the atria are like that. Ventricular fibrillation, or Vfib, again, it's an irregular, rapid, bizarro-looking heart rate, and the ventricles are beating out of rhythm. This is more serious. This, you will unfortunately die if this is not regulated. So ventricular fibrillation, because those ventricles are not beating rhythmically, so that means blood is not getting to the lungs effectively, blood is not getting to the body effectively. So ventricular fibrillation, the ventricles are like, and they're not beating rhythmically. So sometimes use paddles, kind of get the heart back into rhythm. Okay, then an EKG of a myocardial infarction. Well, that's a heart attack. Well, it has an elevated ST. So you can see right here, P, Q, R, and then S. But you see how high this goes? That's not normal. So you can see P, QR, and then my ST right here is elevated. So a heart attack results from blockage in a coronary artery. Muscle cells start dying. Again, we're seeing sometimes in a heart attack, the biggest sign you have to worry about is that elevated ST wave. And then asystole. Remember systole was contraction? Well, A literally means without, like it makes it the opposite. So it's a flat line. There's no electrical activity. Okay, there's one singular beat right here, asystole. What term means slow heart rate? Bradycardia. What term means fast heart rate? Tachycardia. What term means no heart activity? Asystole. What term means heart attack? Myocardial infarction. So what did you learn today? In class, we're going to play a Purkinje. This is a lot, right? So we're going to practice. And that's it. That's the cardiac cycle and EKGs. I hope you learned something new today.